Hello, hello. I want to talk to you a little bit before we go any further about the concept of there's really two different types of integrals that we can take a look at. So, just to kind of review, an integral asks the question, what function has this as a derivative? This comes from the fundamental theorem of calculus that derivatives and integrals undo each other. And there's a concept of integration that is sometimes referred to as anti-differentiation. Anti undoes differentiation. And so you can say, for example, the integral of x plus 4 dx is asking what function, and I'll point out, of x has x plus 4 as a derivative. Okay, and you can ask yourself, what function has x plus 4 as a derivative? Well, I can think of one. For example, 1/2 x squared plus 4x. And it's not that difficult to sort of check that if we run this derivative procedure, we bring down the 2, reduce it by 1, plus, there's an understood 1 there, we bring down the 1, reduce it by 1, we get x plus 4. Perfect. One slight problem. What is the d by dx derivative of something like 1/2 x squared plus 4x minus 5? Well, we do the same procedure. Again, bringing down the 2, reducing it by 1, bringing down the understood 1, reducing it by 1, and then there's an understood x to the 0. We'll bring down the 0, and wouldn't you know it, we also get x plus 4. And this is a real problem because we want to find what is the function for which this has a derivative. And it turns out any constant multiple or constant translation leaves this derivative unchanged, right? The derivative of x and the derivative of x plus 4 are the same. So, whenever you find what we call an indefinite integral, and I want to bring your attention to, it's an integral sign, no boundary. We have to include a plus c, which we call the constant of integration. Okay? So, let's see this in action. Well, what is the indefinite integral of x cubed plus 4x minus 5? Okay? Reminder, dx. What are we going to do? Okay. Same thing. We can actually split this into 3 different indefinite integrals. The antiderivative of x cubed plus 4 times the antiderivative of x minus 5 times the antiderivative of essentially just 1 dx. Although, if it makes you feel better, we can write this as x to the 0, which puts our integral rule a little bit easier. Reminder, we increase, divide, and add a constant. So, what are we going to do? We increase and divide and add a constant. We increase, divide, and add a constant. We increase, divide, and add a constant. But keep in mind, this is a constant, this is a constant, and this is a constant, all 3 different constants. If we do some sort of expanding out real quick, you'll see this is x to the 4 over 4 plus c1 plus 4 times x squared over 2 is going to be 2x squared plus 4 times c2 minus 5x minus 5 times c3. And so we actually have 1, 2, 3 different constants. But we can actually group them together. I'm going to call c, maybe with a squiggle, is equal to c1 plus 4 times c2 minus 5 times c3. Which leaves me with x to the 4th over 4 plus 2x squared minus 5x plus c squiggle. And usually we just omit the squiggle. We just say, look, we're just going to wait until the very end, kind of group all of our constants together. We might pick up a bunch of them, but ultimately they exist as one constant, right? This one, if this one adds 2 and this one adds 9 and this one subtracts 8, doesn't matter. There is one number that will do the work of all of them. So it's real common to omit it here, and omit it here, and just go ahead and add it at the end. Which I also highly recommend that you do. Okay, we can get more interesting. Talking about a little substitution rule. Let's let u be 12x. That makes du equal to 12 dx. The derivative of 12x is 12 times the differential. This is the new integral, e to the u. Now, to get du, I want a 12 here, so I'll divide by 12. And what I find is, this is 1 over 12 times the derivative of e to the u is, sorry, the integral of e to the u is the derivative of e to the u is e to the u. And this is what we do. We just add a constant. So welcome to the club. As college students taking calculus class, you have to always include a constant of integration. And it is annoying. It causes you to miss points on exams and homework questions, and I'm sorry for this. But unfortunately, an indefinite integral asks the question, what has this as a derivative? And the correct answer includes a constant of integration. Okay, so it's just something to always keep in mind. So what's the difference between a definite integral? Well, these have boundary. For example, a definite integral has a boundary. An indefinite integral picks up a constant of integration. Now, I think this is important for college students to see. Why don't I have to deal with constants of integration in a definite integral? Well, real quick, we indefinitely integrate, we anti-differentiate x cubed as x to the 4th over 4. Let's include a c. And we'll do it from -1 to 3. Here's x equals 3. This is going to be this is going to be 3 to the 4th over 4 plus c minus, this is x equals -1, -1 to the 4th over 4 plus c. 3 to the 4, I think is 81. I'm going to check in my calculator. Yep. So this is 81 over 4 plus a constant. -1 to the power 4 is just 1. So minus 1/4 plus c. If we distribute out this negative sign, we get 81 over 4 plus c minus 1/4 minus c. And wouldn't you know it, those things cancel. And the answer is 20. So, do constants of integration exist in definite integrals? Yes. But because of the nature that you're going to subtract them, they're always going to cancel, regardless of what they are. But an indefinite integral will pick up a constant of integration. Specifically, x cubed dx is x to the fourth over 4 plus c. Now I will say, or plus k is real common, but in this class and in this state, and actually I'd say in this country, we use c probably the most. So I just want you to be aware of that. All right, hopefully this integration sections are not giving you as much problems. If you need help, again, reach out. I'd be more than happy to help you, and I'll see you all in the next video.